Now let us see changing the order of integration. In evaluating this double integration, here we are going to use change the order of integration. What do you mean by changing the order of integration? Here the question is double integral dy dx. So this is called as order of integration. So here the order is dy dx. Now we have to change the order, means we have to evaluate this double integral by changing it as dx dy. That is the meaning of changing the order of integration. So how to change? Simply we can't able to change dy dx as dx dx, and simply we can't able to interchange the limits, right? So if you interchange the limits, what happens? This variable limit will go as outermost integral, but it is not correct. Okay, so already I told you that the outermost integral should be constant limit. So for that, first we have to draw the region of integration, then only we can able to identify the limits for the order dx dy. Clear? So now how to change or how to identify the region of integration? First we have to rewrite the limits as equations. So integral, innermost integral x to a, or the limits for the variable y. So we can write the lower limit is what? X. So y is equal to x is one equation. Upper limit is what? A. So y is equal to A is another equation. And what about the limit for x? 0 to a. So x equal to 0 is one equation and x is equal to a is another equation. Now we have to identify the region using these equations. So first the line y is equal to x. How to draw the line y is equal to x? It is a straight line passing through the origin, okay, at an angle 45 degree. So this is the line y is equal to x. What about y is equal to a? It will be parallel to x axis at x is equal to, sorry, y is equal to a. Similarly, what about x equal to 0? This is y axis is x equal to 0. So write like this. What about x equal to a? It is another line parallel to y axis crossing at x is equal to a. So this will be the point a comma a. Clear? And which is the region we have to shade, which is the region of integration for this given problem. So this is the only region bounded by all these equations, that is from x equal to 0 to x equal to a, and from y is equal to x to y is equal to a. So this region you should not consider because this y is equal to 0 is not given in the question. Okay, so like this we have to identify the region of integration. After identifying the region of integration, now we have to identify the new limits. New limits means what? We have to change the order as dx dy. So dx dy means first we have to order is what? Dx dy. So dx dy means first is x. So first we have to identify the limits for x, then only we have to identify the limits for y. As I told you, for x limit we have to draw a horizontal strip that is parallel to x axis. If you draw like this, the left end of the strip touches the line x equal to 0 to what? This is the line y is equal to x, right? Or otherwise x is equal to y. So the upper limit will be y. Clear? Similarly, what about the y limit? How long we can move the strip from bottom to top? Bottom it starts from the origin. So y takes the value 0 to, that is this is origin, to the limit is what? Y is equal to a. So it will be a. So like this we have to identify the limits for x and y by changing the order of integration, right? So now the problem will be double integral 0 to a x to a x square plus y square dy dx. We can write it as double integral x square plus y square is the given function. Now we are changing the order as dx dy. According to this order, the new limits are 0 to y and then 0 to a. Clear? So always variable limits means y will be in terms of x, similarly x will be in terms of y, that is opposite variable. Constant means it will be purely constant. Okay, so this is the way we are changing the order of integration. So by changing the order of integration, the given question can be changed like this. Now we have to do the integration for this term. Now as usual we have to integrate the innermost integral first, that is x variable. So y is treated as constant, so write integral 0 to a as it is. Now y is treated as constant, we have to integrate x. So here x square becomes x cube by 3 plus y square is constant into x. The limits are 0 to y dy. So while applying the limit, we have to substitute the limit only to the variable x because we have integrated with respect to x. So here it becomes y cube by 3 plus y square into y. This is upper limit minus lower limit is 0. So it becomes 0. Now we have to do the integration. So integration of y cube is what? Y power 4 by 4. Already 3 is here, so it becomes 12 plus y cube, this is again y cube, so again y power 4 divided by 4, clear, over the limit 0 to a. So now putting the limit here, a power 4 we can take it as common term, so 1 by 12 plus 1 by 4. So the answer is what? 3. So 4, 12 is the LCM, a power 4. So 1 plus 3 by 12. So the answer is a power 4 divided by 3 is the answer. So this is what we are getting by changing the order of integration. Now let us see the second question. Evaluate double integral over 0 to 3 and 1 to root of 4 minus y x plus y dx dy by changing the order of integration. So here as usual we have to write the limits as equations. So if you see the innermost integral, it has the variable y, which is the limit for the derivative x, so that we can write it as x varies from 1 to root of 4 minus y. So here we can write it as x is equal to 1 one equation and x is equal to root of 4 minus y another equation, and these are the limits for x. Next, the limit for y are y is equal to 0 to 3. So y is equal to 0 to y is equal to 3. So now here since we are having square root of 4 minus y, to remove the square root we can square it on both sides. So we will have the equation as x square is equal to 4 minus y, which represents a parabola, or else we can also write this equation as minus of y minus 4, which means that the parabola is an inverted parabola. Clear? With vertex, what is the vertex for this parabola will be 0, 4. So now we have to consider the diagram in such a manner that we have to consider an inverted parabola. So here let it be x-axis and this is y-axis. First let us draw this equation of a parabola. So since it is an inverted parabola, we can imagine this is an inverted parabola with vertex as 0, 4. Right? Now what about this we have drawn? Now what about x is equal to 1? X is equal to 1 is nothing but, here let us draw this is to be x is equal to 1. Here let us consider this is to be x is equal to 1. Okay, and y is equal to 0. X axis is considered as y is equal to 0. And what about y is equal to 3? Where to draw the line y is equal to 3? For that first we should know this intersection point, and moreover this parabola is what? X square is equal to 4 minus y, and this point is x equal to 1. If you put x is equal to 1 here, we will get y is equal to 3. So this intersection point will be 1, 3. So y takes the value 3 here. So y is equal to 3 represent a line parallel to x-axis which crosses through y is equal to 1. We have to draw like this. Okay, so this is the line y is equal to 3. So now we have to identify the region which is bounded by all these four equations. So this is the region bounded by all these four equations. That is, this is x equal to 1. This is x square equal to 4 minus y is equal to 0, and y is equal to 3. So that here, this is the region of integration. Now for this region of integration, we have to identify the limits. So here, by changing the order of integration, we are going to identify the limits. So first we have to check which should have the variable limit. Here the order is dx dy, which is given in the question, so that we have to change it as dy dx. So first we need to find out the limits for x and then only for limits for y and then for x. So if you want to identify the limits for y, we have to take a strip parallel to y-axis, that is vertical strip. So now we have to check the vertical strip, bottom and the top portion of the vertical strip. Bottom touches the line y is equal to 0 and top touches the parabola x square is equal to 4 minus y. So here the lower limit will be 0 to the upper limit, we have to take it from this equation. So y will be 4 minus x square. Similarly, what about the limit for x? We have to move this vertical strip from left to right. So left means it starts from 1. To the right is it move on like this till this point. So this point we have to consider the point, that is, this is actually x is equal to 1 means this is 1 comma 0. And if you notice this, here you have to put x is equal to 0 here. So if you put y is equal to 0, here x will be plus or minus 2. So here this point will be 2 comma 0. So this is the point x takes the value 2 and this is the point x takes the value 1. So while moving this vertical step, it moves from x equal to 1 to x is equal to 2. So the limits are, x ranges from 1 to 2. So now this is the problem. So our question will be integral 0 to 3 and 1 to root of 4 minus y x plus y dx dy. This is the given question. By changing the order of integration, we have to write it as x plus y. This should be dy dx, and the limits for y is 0 to 4 minus x square, and here it is 1 to 2. So now we have to do the integration only for this new limits, right? Now this is the problem. So now we have to integrate first with respect to y. So x is treated as constant. So integration of this with respect to y will give you xy plus integration of y will give you y square by 2 over the limit 0 to 4 minus x square and dx. So now in place of y we have to substitute the limit. So integral 1 to 2 x into, it becomes 4 minus x square plus here 4 minus x square the whole square divided by 2. So this is what we have to integrate with respect to x. So simply directly we can't able to integrate it. First we have to simplify this. So this term becomes 4x minus x cube. X square is here x. So it is x cube, and then this is x cube. Next here it is 16 minus 8x square plus x to the power 4 whole divided by 2 into dx. So if you want to still simplify this, we can write it as 4x minus x cube. This becomes 8 minus 4x square plus x power 4 divided by 2. So now it is easy to integrate with respect to x. So now integrating this 4x will give you 4x square by 2. Integration of x cube is x power 4 by 4. Here it becomes 8x. Next is 4x cube by 3. Next is x power 5 by 5 into 2 is there. So it becomes 10. Now the limits are 1 to 2. So we have to apply the limit 1 to 2. So as usual you have to substitute the limit, first upper limit minus the lower limit. After substituting it, we will get the answer as 241 divided by 60. So this is the value of the double integration.